one. Tastes like she might be the one. And I can never get enough. I could buy her so much stuff. It's a craving, not a crush, huh? Call me when you're there. I said I bought you something rare, and I left it under Claire. So now she's coming up the stairs, so I'm pulling up a chair. I could eat that girl for I could eat that girl for
Yo, what is going on, people? How's it going? Welcome to this little Friday night live stream. Now this is just going to be not your regular 4-hour stream. This is just going to be a quick little catch up with you guys because it's been a hot minute since I streamed. Been really busy here. Just thought while the opportunity presented itself, I would jump on and see how everything's going, and also look at a couple of amplifiers that I just received some parts in the post for. Including this Alpine PDX M6, which has been giving me some massive headaches with a Class D drive circuit fault on the output side. And I've also got this, where is it? I've got a mains powered PA plate amplifier that had a fault with not powering on at all. So I've got some parts for that as well. I'm going to see if I can get that running. Don't usually do a lot of mains powered stuff, so it's always kind of interesting when I give some of that a go. But how's it going, guys? Good to see you all here. Damin, Sinewave, Leo, Sedon, yo, what's going on, my friend? All you guys, thanks for jumping on. 13BTR, thanks for jumping on as well, my friend. Good to see you here as always. So, first one we're going to be looking at this evening. This is an Alpine PDX M6. This is a little full bridge, expensive, we're very over-engineered little amplifier, and this has come in with, well, it was making a bunch of screeching weird noise on the speaker terminals. Now this is a full bridge amplifier, and one half of the bridge was working fine, and the other channel I was getting absolutely no Class D switching on at all, and tried swapping around all sorts of different parts in the drive circuit here. Swapped the drive ICs around, which are IRS 20956. They're proprietary chips, but you can buy them from AliExpress. So swapped around those, swapped around the bootstrap diodes, capacitors, tested everything. Everything seems fine, but I do get the amplifier working fine when I heat a little area of the board over here. So there's definitely something over in this section here that is the problem. I just was really struggling to find out what the hell what the actual issue is. So what I've done right now is I replaced this part most recently, okay, and this is the first power up that I'm going to do to see whether that's actually made any difference or not. So we're just going to plug some wires in, power wires, just now, and see whether replacing that part has fixed it. I honestly have my doubts. I genuinely don't think that it's going to have made any difference whatsoever, but it was reading a little bit funny, and it was making some strange behavior when I heated it, so that was kind of like the next thing on the list that I wanted to try and change. Now I usually have a little crocodile clip on my remote wire, which seems to have fallen off. Where's that gone? So I'm just going to slightly extend the length of this and just wrap it around. I've got an Allen key just kind of shoved in the thing here. These Alpines, they use these little connector blocks for the terminals here. I don't have one laying about on the workbench just now, so I've just been shoving the wires in, which is fine. Yeah, that's fine, just for a quick test. So probably this isn't going to work, and we're going to be able to see what the problem is and maybe try and diagnose it further on stream today with you. Evening, Steve. Alright, so what I'm going to do is probe. So now this side was good, this side had Class D switching, and this side did not. So I'm going to probe this side, and that's going to be our rail voltage here, I think. Yep, this is going to be our Class D switching, so let's see what we get. Okay, so we get attempts at Class D switching, which you can see here, but nothing's... Oh, there we go. We have Class D switching. No freaking way. Hold on a minute. What about the other side? No freaking way. 430 kilohertz. Ah, okay. Well, it's working a lot better than it was. However, the Class D switching frequency between these two shouldn't be that much different. 360 kilohertz on the good channel versus 430 kilohertz on what was the bad channel. It shouldn't be that much different. Let's just check to see whether these are getting hot. Ah, yeah, okay. So that's a telltale sign that we still have some issues to find. So the side that was giving me grief before I replaced that little component is getting toasty. I suspect that's because the Class D switching frequency is too fast. So if we have a look on our thermal imaging camera right here, actually they're both of these are getting hot. Kind of probably to a similar level actually. Let's have a look on the hat cam. So let's power it up again. Okay, we have Class D switching. Okay, so the good channel currently sitting at 36 degrees and the bad channel is at 45 degrees. So yeah, the channel that had the issue is definitely getting hotter, but I think that's just because it's switching faster. So I think that's the only issue that's left now with this, is that it has the Class D switching frequency is too damn high. Problem is, this is a really complicated discrete Class D sort of drive circuit here. I couldn't tell you right now exactly what sets the Class D switching frequency. So all I've done is I've just changed. The only component that's been replaced is this right here. Q3007. I do have a schematic for this. So I'm wondering whether the transistor that I've replaced just has slightly different specs. It's the same part number, but it could have slightly different specs enough so that it's causing a shift in the Class D switching frequency. So I'm tempted to replace the same transistor on the good side to see whether that equalizes the switching frequencies. Now the only thing that I'm concerned about with doing that is that these parts are glued to the board in addition to being soldered, and that's why I've replaced the one on the other side, is because I actually damaged it taking it off. It's almost impossible not to. So these little transistors here, these are so delicate that even if you use hot air and you melt all of the solder, which obviously would remove the part, but as soon as you try and pull on the part to remove it, it's glued, so it just cracks and snaps in half. So kind of annoying. But I think that's going to be the next thing that we just kind of have to do, really, because we have a difference in Class D switching frequency. The only thing I've changed in this amplifier is this one part here. There's lots of soldering you can see has been going on, but that is all just from swapping parts from side to side, so I haven't actually changed anything. Actually, you know what? I do have a different drive IC in this side, actually. I have AbleTech. I don't think that's the original driver. I mean, they're the same. The you know, different batch of drive IC wouldn't change the Class D switching frequency by that much. So I don't think replacing the AbleTech, the 20956, is actually going to have any difference, you know, make any difference here. So I think my next angle is just going to be to change the transistor up on this good side to see if that affects the Class D switching frequency. If it makes it higher and it brings this Class D switching frequency up to sort of 430 kilohertz, then I'm probably going to leave it there. It's a little faster than maybe it was originally, but that's a good thing in terms of SQ. Technically, it's a higher bit rate, higher sample rate, and although the output MOSFETs get a little bit warm, they're gonna get a bit warm if they're switching that fast. So I don't think that's too much of a problem, really. You know, they're on the heat sink, so they weren't getting to like 80 degrees Celsius in a few seconds. They were gradually climbing up to about 50 degrees there. There is a schematic for this amplifier. I don't think it's on Google. I'm part of a group of repair technicians on Facebook, and there's some files on a group, and it was just on the group. It's part of the group files, so I do have it. I can bring it up if anyone would be interested. You know, should we do that? That might be interesting. Should we bring up the schematic? And so with this complex of a Class D drive circuit, I am not the most knowledgeable about, like, you know, what exactly that is doing, even perhaps when looking at the schematic. What model amp is this exactly? Where's the... here's the heatsink. A second. Is this the PDX M6? Yeah, PDX M6, right. Well, I think I had a schematic for it. Let's have a look. See if we can have a quick look at the schematic. See if I can find it. I've got the V9 schematic downloaded on the PC. Have recent files on here. Okay, let me just search my emails in case somebody emailed it to me. PDX M6. Let's have a look. Nope, just got lots of eBay listings. Okay, let's check the files of my repair technicians group. Files, search M6, PDX. No, so I've only got PDX V9 or PDX 10K. I'm sure that I did find a schematic though the other day when I was in the workshop. M6. No, maybe not. Okay. In that case, I don't have schematic. But I've got the PDX 1.1000, PDX 5, MRV, but none of them are the exact same circuit as this. So, okay, my bad, I don't have a schematic. But either way, like I say, I think the angle right now is to just go ahead and change this transistor up here with one that I've got that I ordered for a different bank, and just see whether that affects the Class D switching frequency. If not, then no harm done. If it does, then, you know, that's just going to have to be where it sits, I think. Oh guys, I need a new soldering iron. So I've had my AOUA soldering station ever since I started amplifier repair way back. Oh, how long ago now? 8 years maybe? I don't know. And my AOA station has done me solid. It still works fine. Don't get me wrong. The soldering station is still good. The problem I have is that these soldering stations, they have the heating element for the soldering iron in the tips. The tips are these long stick things, which I think I've now thrown in the bin. But yeah, the tips are these long stick things which have the heating element in the tip, but it's like slightly back from the tip. And because of that, these tips are like light bulbs and they have a finite lifespan, and the heating elements, the filament, whatever it is, it fails over time. Sometimes the tips last me 2 years. Sometimes they last me 1 hour, which was the unfortunate occurrence I had. I bought 2 new tips from eBay recently, and both of them lasted about an hour and a half. And I'm sending them back because they're obviously bad, you know. I haven't changed anything about my setup and how I use them. The tips I had previously lasted me 1.5 years, and these ones last me an hour. So, but I'm kind of bored of keep buying these tips, and I would like an upgrade to my soldering iron. So I'm going to be looking around to see what I can find. I want something like at least 80 watts with really good material on the tip that's not going to degrade and heats up fast, good thermal mass. I've obviously got the massive one. I've obviously got the massive 200 watt Weller, which is great for like actually a lot of things. You know, I can actually get quite intricate with this still, even though it's so big. But I do need a more sensible sized iron for, you know, just general stuff. I can't be using that for surface mount reflowing and whatever. So let's hit the thermal gun and let's get this right. Now, like I said, what I'm going to try and do is I'm going to try and remove this transistor without damaging it, but I believe it will be impossible. But that's okay because I have spares. But like I say, these parts are all glued to the PCB in Alpine amplifiers. So it makes it very difficult to get these size and delicacy of parts off without just breaking them in half, basically. I'm going to start by preheating the area of the board to prevent popcorning. Going to give a little poke at these legs just to see whether the solder is kind of melting or not. Not quite yet. And then once it looks like the solder is kind of melting or melted, I'm going to start trying to pull on the part, but I don't think it's going to come away, like I say, because it's glued, and the glue isn't the sort of glue that melts with you know, that goes soft with heat. So you kind of just have to try your luck with pulling it hard. 13BTR says, I was singing your praises the other day. I was able to troubleshoot and fix an Alpine 3545 using skills I learned from you. Man, that's awesome. I love to hear that. Honestly, that's the best kind of thing that I can hear. Feel free to go into some more details. What sort of issues did you have, and what sort of skills were you using? What was the issue with it, and what did you have to do to fix it? I'd love to know. This board could also really do with being preheated, but my large hot air gun that I use for preheating boards, it's actually still connected up in series with a mains power plug, because I was using it to act as a series resistance. See, there we go. It just literally breaks in half. So the top half of this transistor here has just come off, I think, with the die, and the bottom half is just like stuck there on the board. I don't know if it's going to focus close enough to really see that, but yeah, that's just what happens with these parts, unfortunately. So you have to now just heat it up enough to scrape it off. Hey Sam, I have a JBL car amplifier that uses TIP35C. What's a good replacement? You can still get those parts, so I would recommend replacing with the 35C. They're still available as far as I'm aware. Alternatively, you just want to look for like an audio grade transistor that is similar specs in terms of voltage and current, that is, you know, designed for use in audio amplifiers. But obviously you wouldn't then just be able to replace that one transistor. If you were changing the model of transistor, you'd have to replace all of them on that channel. Ideally all of them in the whole amplifier, but at least all of them in that one channel. So the little transistors that I have to replace that with are here. Now I'm going to reflow these solder pads, but unfortunately, because I don't have a working soldering tip at the minute for my AOO station, I'm going to have to do it with the Weller. You're about to see some obnoxiously large soldering iron trying to do tiny intricate work right now. I mean, just look at this ridiculous monstrosity trying to get in there on some tiny things. Like it'll work, it'll be fine. I've got a corner there that I can do it with, and plenty of flux, but it's just clumsy. It's not ideal. What MOSFETs you could use on the output section apart from B38N20D, as these are no longer available. The Emerson Audio Bank. Sounds like that might be one of those jank ass discrete Class D freaking old ass amps from the early 2000s. I'd recommend throwing it in the bin. But if you really want to get that working again, then the thing that those drive circuits, if it's one of those amplifiers that's using a completely discrete drive circuit, by that I mean the drive circuit consists of all individual transistors, resistors and diodes, like one of the driver cars has got like fucking tons of transistors on it, then they rely heavily on the gate capacitance. The gate capacitance is really important. So look at the original FETs, 38N20s and also the 31N20s, check the gate capacitance, the input capacitance, and try and choose some FETs that have as close to the original gate capacitance as possible. Also VT, the turn on threshold, is also kind of important in those amplifiers with how they switch. So try and match the VT and the CG, and then you should be fine. I'm pretty sure that some people have used the 42N20s and they've been alright in those kind of amps. This soldering iron isn't quite heated up enough yet. Still needs a little bit of time to get hotter, because you can see it's not really melting. It's starting to go now, but this takes a while to heat up this one just because it's so big. Reflow. Now the problem with this is sometimes if you're not careful you can end up pulling a surface mount resistor off the board just with the size of this. So there we go, okay. Reflowed clumsily with the Weller. Now we need a bit of flux. With a little bit of flux we can make it through the night. It needed a full recap. After replacing the caps, it would power up. Started checking transistors, 2 in the DC offset circuit and 1 in the dead time. For the pass by failed. Damn, that's a random failure. That's like a bunch of weird uncorrelated like issues. That's a good job. Yeah, that's freaking cool. When you find and fix those kind of faults, it feels wicked. I've got a not a similar, but I've got the PA plate amplifier that we're going to be looking at possibly next. Has some strange, well, it had a bit of a complex fault as far as I'm concerned, and I'm quite proud that I managed to diagnose it, provided that I have actually diagnosed it correctly. I don't know yet. I'm going to fit some parts, but yeah, when you figure out some of these really complicated ones, you know, that have really strange faults, or maybe the whole amplifier isn't coming on or it's not working, and the only issue is like one tiny component. like tiny little surface mount capacitor or resistor somewhere, but you manage to hone in and find it, and you just replace one tiny component and the whole thing works again, that always feels fantastic. Alright, okay, cool. We are soldered. Alright, so I'm just gonna let that cool down a little bit, and I'm just going to be really interested to see whether the Class D switching frequency of both of these banks is now equal. Got a little inkling that it's not going to be. I've got a little inkling that there's still a fault on this side that's causing the switching frequencies to be too high, but we'll see. Random question, do you still have the BenQ Trevolo Bluetooth speakers? Yes, I use them for background music in my dining room at dinner time. Not the best use for them because they're best used on axis, like sat down listening to them at equal distance and stuff, but it's good use for them. They sound cool. I was looking for one, but sadly they're not in Germany. Yeah, I still have my pair. I don't need them, to be fair. You know, I'd probably rather actually have a pair of bookshelf speakers in there on like an old integrated amp or something, but yeah, no, I do still have them. They're cool and they do sound good, but they're not the best Bluetooth speaker. Like, you know, they don't go very loud, but they do, and they don't go very loud, and the sound is very directional. So they only really sound good if you're like sat planted right in front of it, or like, you know, on axis to it. As soon as you go off axis, they don't sound great. So, you know, they're not the best Bluetooth speaker for just putting down and walking away and having on in a room where you're moving about. But they are good if you want to take like a really nice, high quality, hi-fi sounding electrostatic sound away with you to a hotel, and you want to set them up and sit in a hotel and, you know, critically listen to some music. Then it's cool, because there's not really many Bluetooth speakers you can do that with. So how are we for temperature? Oh yeah, it's cooled down pretty quick. Alright, cool. Let's go for a power up and see what the Class D switching frequency is now of both of these banks. So Class D was here. Ooh, oh dear. Something is wrong. We have high current draw. Ah, okay. Well, that's interesting. So the channel that was working now isn't working. Great. Excellent. Fantastic. Immense. And the channel that was originally not working is now doing the same thing that it was before I replaced that part. So you can see here the Class D switching frequency is miles too fast, and this is the issue I was having before. This is why this is basically in for repair. So you can see it's miles too fast, and we've got quite a high current draw. Now if I take the hot air gun, okay, and if I blow some hot air around this area of the drive circuit, let me zoom in, you'll see that the switching frequency starts to settle. So you can see it's all sorts of messy. Now if I heat up this area here and try again, there you go, sorted. Bit of hot air and it sorts itself out. So clearly the issue is somewhere over here. But it's not consistent, as you can see. It didn't fix itself then, even though I was blowing some hot air around a bit. And I can't leave it on for too long, because with the Class D switching frequency as high as it is at the moment in this kind of fault mode, the Alpine MOSFETs get freaking cooking, like really hot. There we go. Okay. Well, it's definitely one of these transistors around here, so I think I'm just going to have to keep changing transistors until I hit jackpot. But more concerningly now is, what the hell have I done to the channel that was working? All I did was change that transistor. It's not the incorrect part, because these channels are just mirror images of themselves. So what have I done? Why is this channel now not working? That makes no sense. Very sad. Made it worse. But I don't know why. I think this is just kind of what happens when you work on Alpine amplifiers like this. This is just like your typical Alpine repair experience. What I'm going to do is turn the scope on to normal trigger, which should give me a bit more information about what's going on here. Right, just got a pulse. Okay, so great. This is now what the good channel is doing. Amazing. So why would it start randomly doing that after just replacing that transistor, huh? This exact same part number, nothing has changed. And the bad channel is wee all over the place. Sick. So I think that one's getting put to the side for a bit longer, because I think I'm already over the amount of hours that I should really be spending on this one. For, you know, how much am I going to get for this repair? Like, I mean, this amp's worth like 130 quid at best, and I think I'm already like 4 hours deep, which is £200. So yeah, this is probably going to be like not really viable to repair. These Alpines are mega complex, and all the sorts of gremlins that appear are just a freaking nightmare. So yeah, why replacing that transistor up here for a like-for-like exact same model transistor now has broken that previously working channel is beyond me. But there you go. That's the beauty of working on Alpines. So let's get this off the bench, and instead let's just drop the mains powered amp and show you what I found on that one. Okie dokie. This is a plate amplifier for a big speaker. So what this thing consists of is very simple. In fact, we have a mains voltage input pre-buffer board thing, a couple of inductors, a couple of caps. That then gets fed into the main power supply board, which is a switching power supply. We have a full bridge rectifier, and we have bulk capacitors, we have a little transformer, we have a single MOSFET, I think. Yep, we have a single MOSFET here, which appears to be the single MOSFET which is driving this transformer, with the oscillator here, very, very simple bits, and we have rectifiers here on the other side of the transformer, and then some capacitors for storing the rail voltage, can only assume. And then we move on to the actual amplifier board, which is tiny, teeny tiny. Actually, I think this transformer actually has two secondaries, perhaps. I think it has a secondary here and a secondary here, and it's generating two different rail voltages, which is why we have two sets of rail caps here. Possibly, I haven't gone that deep into it, because on this amplifier board we actually have a TDA 8924TH, which is a Class D full integrated amplifier IC, and then we have another TDA integrated amplifier IC up here. So this is probably going to be for tweeter and woofer, for example, in this active speaker. Yeah, it is high frequency, low frequency. So Now, the fault with this was that it wasn't powering up at all. Yeah, no power. And I was sort of digging around with it and stuff, so no sound, no power. I was first of all looking at this, the TDA chip, because these are pretty delicate and they're like the most common thing that's going to fail. And it wasn't showing me any signs of being bad, to be honest. I wasn't getting any Class D switching at all. We've got our output inductors here. It's like, I think it's a 2-channel. It's been running full bridge. So we've got output inductors here. So I wasn't getting any Class D switching on this chip. Also this amplifier chip here for the tweeter, I was getting just very, very, very faint, like treble, very, very faint output. And that was with the the gain absolutely whacked out to the max. So it was making some sound but very faint and only through the tweeter. So I pulled up the datasheet of this TDA chip and I found that actually it was in muting mode. So there's one pin up here that will set the chip into different modes depending on the amount of voltage on that pin. So in order for the chip to be active, it needs 5 volts on it, I believe. And it currently had 0 volts, which is, I think, standby or mute. So I then spent a while tracing back and trying to figure out, right, where does this kind of mode or mute signal come from? There's a bunch of components on the board here. There's also a muting pin on this amplifier IC up here as well, and that was also set to mute. So both of these ICs were like being told to mute or to be on standby rather than active. So quite a lot of digging and reverse engineering. I don't have a schematic for this circuit at all, so it's all just been reverse engineered by me looking at it and figuring it out. Turns out that there is the kind of muting circuit comes all the way back to the power supply board, and I guess the amplifiers are told to mute until the rails are built and a small amount of time has passed, like a soft start, and then they will come out of mute and start working. And the muting circuit works off of this optocoupler down here. So what we have is a little circuit here that charges from the negative rail voltage, negative 28 volts. It charges a capacitor, which I think might be this one right here, possibly. I can't remember, it might be this big one actually here. It charges a capacitor through a resistor basically, and then once enough voltage is in the capacitor, it then sends a signal. It then basically energizes the optocoupler, which then sends a sort of 5-volt signal from the optocoupler down the muting circuit to unmute all of the amplifiers. So what I found was that the optocoupler seemed to be bad, so I've soldered a new optocoupler in. The reason it's on the underside of the board rather than the top is because I did have this model of optocoupler in stock, but it was the surface mount version, not the through-hole version. So I've just soldered the surface mount version to the underside of the board in the correct orientation. That's fine, no problems with that. There's more than enough clearance. There's no problems at all, just different side of the board. And also I found that the resistor, which is responsible for stepping the voltage, the 28 volts down to about 2 or 3 volts for the LED in the optocoupler, that was open. There's supposed to be I think it's a 330k, which is going to be, oh no, sorry, it's a 33k. Here we go. So I needed a 33k, which has now arrived. So my theory is that once I put this new resistor in, this whole thing should come to life. There's my wishful thinking. It could also explode. Who knows? So because this is a mains amplifier, obviously I'm live streaming from the PC. So if it explodes and trips my breaker, then the live stream will go off. And so if the live stream suddenly ends as I'm testing this, then you know why. Oh man, 13BTRX. I'll chip in on the Solder Station Fund. Thank you very much, man. That's very kind of you. You're always very generous with your donations, buddy. I really appreciate that. It definitely help a lot. If anyone's got any suggestions for... Now, I'm not looking for a branded soldering station. I don't want a Hacko. I don't want anything that's got like brand tax. I'm kind of looking for something like Chinese brand off AliExpress that just so happens to be like freaking awesome, that type of thing, you know. Something really, really cheap, but the, oh, hey, this actually works really well type of vibe. Or something secondhand off Marketplace, but obviously, you know, you won't be able to really advise me on that. That's just going to be luck of the draw as to what's available at the time. But yeah, if anyone's got any suggestions for modern digitally controlled soldering irons, doesn't have to be a station, just a single iron, let me know. Right, come on, you big ass thing, get up to temperature again. I'd love to see a comparison between a hi-fi amp and a car audio amp to see why hi-fi amps cost thousands per watt versus car audio. Most of it is, unfortunately, especially in home hi-fi specifically, it's just a lot of brand tax and snake oil, genuinely. And it's sad to say, you know, there will be some amplifiers, some hi-fi amplifiers, which are genuinely pieces of engineering masterpiece, and so what you're paying for in the price is going to be the R&D and the engineering that went into designing that circuit from scratch, and all of the wages of the engineers and all of the marketing and everything that comes with that. But in terms of the actual circuit itself, yeah, there's no need for a circuit to be that expensive as a lot of these hi-fi amps, high-end ones are. You're either paying for the luxury of having a specific brand, or you're actually paying for a lot of R&D and sort of, you know, costs associated with bringing that thing to market. With car audio, it's less prestigious. So, you know, brands aren't going to need to make things be as expensive to give off the illusion of them being as good, if that makes sense. And also because car audio users and consumers are less fussy, they don't need to make the circuits be as good, because when they're used in an automotive environment, a lot of the nuances that make up a beautiful sounding amplifier are kind of lost in the environment that is car audio. So a lot of the circuits in car audio are just kind of recycled generic stuff that doesn't cost a lot of money to R&D and to bring to market, or it's, you know, just recycled circuits from China. So that's why it's pretty cheap. And typically people that are into, you know, the mass market that is into car audio generally doesn't have a lot of money. Like, you know, yeah, of course there's guys that spend big money on car audio build.